we ready for the age of the quantum computer?
It's the first time that we are inventing computing in 70 years. Quantum being more transformational than many other computing technology. That is the first time we are branching, is big, no doubt.
Depending on who you ask, some say these hyper-powerful devices could either break the internet, rendering pretty much every data security protocol obsolete, or allow us to compute our way out of the climate crisis. Its backers also say it could help us develop everything from new materials, say lighter electric vehicle batteries for example, to new pharmaceuticals. And while it might sound a little fantastical, tech giants like IBM, Google, Amazon and Microsoft are betting big on a quantum future, and are already hard at work building these new wonder machines.
Here we are at the IBM Research Lab in Zurich, where we perform experiments on quantum computing.
So how exactly will quantum revolutionize computing? For starters, think of all the devices that we have today. From the smartphones in our pockets to our most powerful supercomputers. These operate and have always operated on the same principle of binary code. Essentially, our computers use tiny transistors operating as on-off switches to give two possible values, 0 or 1, or bits as they're called, short for binary digits. These bits can be combined into larger units, essentially strings of zeros and ones in different combinations to form a kind of code which computers then process into data that tells it what to do. Display a video, show a Facebook post, let you type an email, play an MP3. All of these digital assets are essentially long strings of encoded bits. But quantum computers? They're a whole other ballgame. These systems rely not on binary code, but rather exploit the properties of quantum mechanics, the field of science focusing on the physical properties of nature at the scale of atoms and subatomic particles. So, say goodbye to bits and enter stage left, the qubit, the basic unit of information in a quantum computer.
The qubit, in principle, is a two-level system that enables to store quantum information. Again, instead of having only the two levels, 0 and 1, that you would have in a classical calculation, here we can build a superposition of these two states.
Superposition in qubits basically means that unlike a binary system with its two possible values, 0 and 1, a qubit can be 0 or 1, or 0 and 1 at the same time. And if you can't wrap your head around that, think of it this way. A coin has two faces, heads or tails. But if you spin it, or flip it, in a way it is both heads and tails at the same time while flipping or spinning, until it lands and you can measure it. And for computing, what that means is that instead of encoding information in zeros and ones, you have an exponentially larger amount of states in which to encode data. This makes quantum computers exponentially more powerful than traditional binary code computers.
So you understand that when you put together many qubits and you have structure that can get at the same time all values between 0 and 1, naturally you can eventually store much more information.
In an admittedly simplified nutshell, that's how quantum computers work. So why do we need quantum computers?
Quantum computer is going to make much easier the simulation of the physical world. What is the outcome of the ability to simulate better atoms and molecules? We can understand better the properties of atoms and molecules and materials, designing of new materials with tailored properties. If I am able to design a better material for energy storage, I solve the problem of mobility. If I'm able to design a better materials as a fertilizer, I'm able to solve the problem of hunger and food, the production. If I'm able to design a new materials that allow to do CO2 capture, I'm able to solve the problem of climate change.
But there could also be some undesirable side effects. A primary concern is that quantum computers of the future could be possessed of such powerful calculation ability that they could break the encryption protocols fundamental to the internet that we have today.
When people communicate over the internet, anyone can listen to the conversation, so they have to first be encrypted. And the way encryption works, between two people who haven't met, they have to rely on some algorithms known as RSA or elliptic curve, Diffie-Hellman, to exchange a secret key. Exchanging this secret key is the hard part, and those require some mathematical assumptions which become broken with quantum computers.
Organizations like IBM are already turning their attention to preparing quantum-safe algorithms to secure data in the quantum age.
Even if we don't have a quantum computer, we can write algorithms for it. We have concrete expectations for what a particular quantum computer will do and how it will break certain encryption schemes. So we can definitely prepare for things like that. And it makes sense to prepare for things like that because we know exactly what they're going to do.